OSI model layers. Physical layer. Layer 1. Purpose. Deals with a physical connection between devices, components, cables, switches, and NIC, network interface cards. Functions. Signal transmission and reception. Protocols. Ethernet, USB, Bluetooth. Contrast. Unlike other layers, it doesn't deal with any logical aspect of networking. Data link layer. Layer 2. Purpose. Responsible for creating a reliable link between two directly connected nodes. Components. MAC addresses, switches. Functions. Frame sequencing, error control, and flow control. Protocols. Wi-Fi, Ethernet. Contrast. Unlike the physical layer, it adds a control header to the data. Network layer. Layer 3. Purpose. Determines the best path to transfer data from source to destination. Components. Routers, IP addresses. Functions. Routing, logical addressing, and packet forwarding. Protocols. IP, ICMP. Contrast. Focuses on packet forwarding, unlike the data link layer, which focuses on frame sequencing. Transport layer. Layer 4. Purpose. Ensures end-to-end communication and data integrity. Components. Ports, sockets. Functions. Segmentation and reassembly, error detection, and flow control. Protocols. TCP, UDP. Contrast. Unlike the network layer, it ensures that the entire message reaches the destination intact. Session layer. Layer 5. Purpose. Manages sessions or connections between applications. Components. APIs, sockets. Functions. Session establishment, maintenance, and termination. Protocols. RPC, SQL. Contrast. Focuses on dialog control, unlike the transport layer, which focuses on end-to-end communication. Presentation layer. Layer 6. Purpose. Translates the application format to network format and vice versa. Components. Syntax translators, encryption/decryption. Functions. Data translation, encryption, and compression. Protocols. JPEG, GIF, MPEG. Contrast. Unlike the session layer, it deals with data format rather than the connection. Application layer. Layer 7. Purpose. Provides a user interface for network applications. Components. Browsers, email clients. Functions. File transfers, email, network management. Protocols. HTTP, FTP, SMTP. Contrast. Unlike the presentation layer, it provides end-user services. Summary of contrasts. Physical versus data link. Physical deals with hardware and electrical signals, while data link adds a control header for frame sequencing. Data link versus network. Data link focuses on frame sequencing, while network focuses on packet routing. Network versus transport. Network deals with packet forwarding, while transport ensures end-to-end data integrity. Transport versus session. Transport ensures data integrity, while session manages the connection. Session versus presentation. Session focuses on connection management, while presentation focuses on data format. Presentation versus application. Presentation deals with data format, while application provides end-user services. Data encapsulation components. Ethernet header, Layer 2, data link, purpose. To identify the source and destination MAC addresses. Components. Source MAC, destination MAC, ether type. Layer. Data link. Contrast. Unlike IP headers, Ethernet headers do not contain information about the network layer, IP addresses. Internet Protocol, IP, header, Layer 3, network, purpose. To route packets from source to destination across networks. Components. Source IP, destination IP, time to live, TTL, protocol. Layer. Network. Contrast. Unlike Ethernet headers, IP headers contain logical addressing, IP addresses, and routing information. TCP. UDP headers, Layer 4, transport, purpose. To ensure end-to-end communication and data integrity. Components. Source port, destination port, sequence number, TCP, acknowledgement number, TCP. Layer. Transport. Contrast. TCP is connection-oriented and reliable, while UDP is connectionless and faster but less reliable. TCP flags. Part of TCP header. Purpose. To control various aspects of the TCP connection like setup, teardown, and data transfer. Components. SYN, synchronize, ACK, acknowledge, FIN, finished, RST, reset, etc. Layer. Transport. Contrast. Unlike other header fields, TCP flags are specifically used for connection management. Payload. Layer 7, application, purpose. The actual data that needs to be sent. Components. User data, files, messages. Layer. Application. Contrast. Unlike headers, the payload is the actual content and not metadata. Maximum Transmission Unit, MTU, purpose. To specify the largest packet size that can be transmitted. Components. Size in bytes. Layer. Network, but affects all layers. Contrast. Unlike headers and payload, MTU is a constraint on the size of the data packet. Summary of contrasts. Ethernet header versus IP header. Ethernet focuses on MAC addresses and local delivery, while IP focuses on logical addressing and routing. IP header versus TCP. UDP headers. IP is for routing, while TCP. UDP headers are for end-to-end data integrity and delivery. TCP headers versus UDP headers. TCP is reliable and connection-oriented, while UDP is faster but less reliable. TCP flags versus other headers. TCP flags are specific to TCP and are used for connection management. Payload versus headers. Payload is the actual data, while headers are metadata. MTU versus headers. Payload. MTU is a size constraint, while headers and payload are data components. Encapsulated TCP packet example. Ethernet header. Source MAC address. Destination MAC address. Ethernet type. IP header. Source IP address. Destination IP address. Time to live. Protocol. TCP. TCP header. Source port. 8080. Destination port. 80. Sequence. 1001. Acknowledgement. 1002. Flags. Synchronize. Acknowledgement. Payload. Hello, world. Ethernet. CRC. Explanation. The Ethernet header is the first to be added, containing the MAC addresses and indicating that the next section is an IP header. The IP header is added next, containing the source and destination IP addresses and other routing information. The TCP header follows, containing the source and destination ports and other control information. The payload is the actual data to be sent, hello, world, in this example. Finally, the Ethernet trailer is added, which contains a CRC value for error checking. This encapsulated packet would travel through the network, and each layer would be decapsulated at the destination to extract the original payload. UDP packet encapsulation. Ethernet header. Source MAC address. Destination MAC address. Ethernet type. IP header. Source IP address. Destination IP address. Time to live. Protocol. UDP. UDP header. Source port. 8080. Destination port. 53. Length. 12. Checksum. Payload. Hello, UDP. Ethernet trailer. CRC. Explanation. The Ethernet header is the first to be added, containing the MAC addresses and indicating that the next section is an IP header. The IP header is added next, containing the source and destination IP addresses and other routing information. The UDP header follows, containing the source and destination ports and other control information. The payload is the actual data to be sent. Hello, UDP, in this example. Finally, the Ethernet trailer is added, which contains a CRC value for error checking. Network topologies. Mesh. Characteristics. Every device is connected to every other device. Advantages. High redundancy, fault tolerance. Disadvantages. Complex, expensive. Star/hub and spoke. Characteristics. All devices connect to a central hub. Advantages. Easy to install and manage. Disadvantages. If the hub fails, the whole network goes down. Bus. Characteristics. All devices are connected to a single central cable. Advantages. Easy to set up, low cost. Disadvantages. Limited length and number of devices. Ring. Characteristics. Devices are connected in a closed loop. Advantages. Easy to install and set up. Disadvantages. Failure in any cable breaks the loop. Hybrid. Characteristics. Combination of two or more topologies. Advantages. Flexible, scalable. Disadvantages. Complexity. Network types and characteristics. Peer-to-peer characteristics. Direct connection between devices without a central server. Use case. Small networks, file sharing. Client-server. Characteristics. Central server provides resources to clients. Use case. Corporate networks, web services. Local area network, LAN. Characteristics. Limited geographical area, high data rates. Use case. Home, office. Metropolitan area network, MAN. Characteristics. Spans a city. Use case. Connecting multiple LANs within a specific geographic area. Wide area network, 1. Characteristics. Large geographical area, slower data rates. Use case. Internet. Wireless local area network, WLAN. Characteristics. LAN but wireless. Use case. Wi-Fi networks. Campus area network, CAN. Characteristics. Spans a university or campus. Use case. Educational institutions. Storage area network, SAN. Characteristics. High-speed network of storage devices. Use case. Data centers. Software-defined wide area network, South Dakota 1. Characteristics. One managed using software-defined networking. Use case. Enterprise networks. Multi-protocol label switching, MPLS, characteristics. Routes data using path labels instead of IP addresses. Use case. Telecommunication networks. Multi-point generic routing encapsulation, MGRE, characteristics. Allows for multiple endpoints for VPNs. Use case. Complex VPN setups. Service-related entry points. Demarcation point. Characteristics. Point where provider's responsibility ends and customers begins. SmartJack. Characteristics. Advanced type of network interface for managing and diagnosing problems. Virtual network concepts. Switch. Characteristics. Virtual switch operating at the data link layer. Virtual network interface card. VNIC. Characteristics. Virtualized network interface. Network function virtualization, NFV. Characteristics. Virtualizes network services like load balancing. Hypervisor. Characteristics. Manages virtual machines. Provider links. Satellite. Characteristics. Global coverage, high latency. Digital subscriber line, DSL. Characteristics. Uses telephone lines, moderate speed. Cable. Characteristics. Uses cable TV lines, high speed. Leased line. Characteristics. Dedicated line, high cost. Metro optical. Characteristics. High speed, metropolitan areas. Cable types and connectors. Copper cables. Twisted pair. Cat5. Suitable for 10-100 megabits per second networks, up to 100 megahertz. Cat6. Supports up to 1 gigabits per second, 250 megahertz. Cat6a. Supports up to 10 gigabits per second, 500 megahertz. Cat7. Supports up to 10 gigabits per second, 600 megahertz, shielded. Cat8. Supports up to 25 to 40 gigabits per second, 2000 megahertz, shielded. Coaxial/RG-6. Used for cable TV and internet, supports up to 1 gigabits per second. Twinaxial. Used in data center environments, supports up to 10 gigabits per second. Termination standards. TIA. EIA-568. R&B. Standards for connecting twisted pair terminations. Fiber cables. Single mode. Long distance, high-speed data transmission. Multi-mode. Short distance, lower speed data transmission. Connector types. LC, local connector, St. Straight Tip, South Carolina, Subscriber Connect, Montana, Mechanical Transfer, RJ, Registered Jack, General Purpose Connectors for Fiber and Copper. APC. Angled Physical Contact, used for high-precision fiber networks. UPC. Ultra-Physical Contact, improved version of PC connectors. RJ11, RJ45. Used for telephone and Ethernet respectively. F-Type. Used for cable TV. Transceivers and media converters. SFP. Small form factor pluggable, up to 1 gigabit per second. SFP Plus. Enhanced version, up to 10 gigabits per second. QSFP. Quad SFP, up to 40 gigabits per second. QSFP Plus. Enhanced version, up to 100 gigabits per second. Cable management. Patch panel. Patch bay. Organizes cable connections. Fiber distribution panel. Organizes fiber cables. Punch-down blocks. 66, 110, Chrome, BICs, used for terminating twisted pair cables. Ethernet standards. Copper. 10 base T, 100 base TX, 1000 base T, 10G base T, 40G base T. Fiber. 100 base FX, 100 base SX, 1000 base SX, 1000 base LX, 10G base SR, 10G base LR. Wavelength division multiplexing. Course. CWDM, dense. DWDM, bidirectional. WDM. Appropriate type for solutions. Home networking. Cat5e or Cat6 with RJ45 connectors. Small business. Cat6 or Cat6a with patch panels for management. Data centers. Single-mode fiber with SFP plus or QSFP plus transceivers. Long-distance transmission. Single-mode fiber with DWDM technology. Cable TV. Coaxial with F-type connectors. High-speed, short-distance. Multi-mode fiber with LC or South Carolina connectors. Voice systems. Twisted pair with RJ11 connectors. Industrial settings. Cat7 or Cat8 for resistance against interference. Public versus private networks. RFC 1918 defines the IP address ranges that are reserved for private networks. These ranges are not routable on the public internet. Class A 10 0 0 0 2 10 255 255 255. Class B 172 16 0 0 2 172 31 255 255. Class C 192 168 0 0 2 192 168 255 255. Network Address Translation, NAT, translates private IP addresses to a public IP address for Internet access. Port Address Translation, PAT, a type of NAT where multiple devices on the local network are mapped to a single public IP address with different port numbers. IPv4 versus IPv6. Automatic Private IP Addressing, APIPA, automatically assigns a local IP address when a DHCP server is not available. Used in IPv4. Extended Unique Identifier, EUI-64. Used in IPv6 for auto-generating an interface ID. Multicast. Sending data to multiple recipients. Unicast. Sending data to a single recipient. Anycast. Sending data to the nearest of multiple recipients. Broadcast. Sending data to all devices in the network. Exists in IPv4 but not in IPv6. Link local. IP addresses that are used only for communications within the local network. Loopback. IP address to test network software 127.0.0. 1 in IPv4, ::, 1 in IPv6. Default gateway. The IP address of the router that connects a local network to other networks. IPv4 subnetting. Classless, VLSM. Allows for arbitrary subnetting. Classful, A, B, C, D, E. Old method based on fixed ranges. CIDR notation. Represents both the IP address and network mask. 192.168.1.0/24. IPv6 concepts. Tunneling. Encapsulating IP6 packets within IP4 packets for routing through IP4 networks. Dual stack. Running IP4 and IP6 simultaneously. Shorthand notation. Condensing IP6 addresses by omitting leading zeros. Router advertisement. Part of Slack, routers advertise their presence along with various link parameters. Stateless address auto-configuration. Slack allows IPv6 devices to configure themselves automatically. Other concepts. Virtual IP, VIP. An IP address that doesn't correspond to an actual physical network interface. Used for load balancing and failover. Subinterfaces. Virtual interfaces created on a physical interface, often used for routing and LAN separation. Common ports and protocols. File transfer. FTP, 20 data and 21 control. Used for file transfers. Encrypted alternative. FTPS, FTP secure, SFTP, port 22, SSH, 22. Secure shell for secure remote login. SFTP, 22. Secure file transfer protocol, runs over SSH. SMB, 445. Server message block for file sharing. Remote access. Telnet, 23. Remote terminal connection. Encrypted alternative. SSH, port 22, SSH, 22. Secure shell for secure remote login. RDP, 3389. Remote desktop protocol for Windows. Encrypted alternative. RDP over SSL/TLS. Email. SMTP, 25. Simple mail transfer protocol for email. Encrypted alternative. SMTP over TLS, port 587, POP3, 110. Post office protocol for email retrieval. Encrypted alternative. POP3S, port 995, IMIP, 143. Internet Message Access Protocol for email. Encrypted alternative. IMAPS, port 993. Networking. DNS, 53. Domain Name System for Name Resolution. DHCP, 67 Server and 68 Client. Dynamic Host Configuration Protocol for IP Assignment. NTP, 123. Network Time Protocol for Time Synchronization. SNMP, 161 Agents. Polling and 162 Asynchronous Traps. Simple Network Management Protocol for Network Management. Syslog, 514. For network logging. Web. HTTP, 80. Hypertext Transfer Protocol for web traffic. Encrypted alternative. HTTPS, port 443, HTTPS, 443. HTTP Secure, uses SSL. TLS for encryption. Directory Services. LDAP, 389. Lightweight Directory Access Protocol. Encrypted alternative. LDAPs, port 636. Session Initiation Protocol. SIP, 5060 Clear Text and 5061 TLS encryption. Session Initiation Protocol for VoIP. Databases. SQL Server, 1433. Microsoft SQL Server. SQLnet, 1521. Oracle Database. MySQL, 3306. MySQL Database. IP Protocol Types. ICMP. Internet Control Message Protocol, used for error reporting. TCP. Transmission Control Protocol, connection-oriented. UDP. User Datagram Protocol, connectionless. GRE. Generic Routing Encapsulation, for tunneling. IPsec. Internet Protocol Security, for secure communication. AH Authentication Header. ESP encapsulating security payload. Components of IPsec. Connection types. Connectionless. Does not establish a connection before sending data, UDP. Connection-oriented. Establishes a connection before sending data, TCP. Use and purpose of network services. DHCP, Dynamic Host Configuration Protocol, scope. Defines the range of IP addresses that the DHCP server can allocate to clients. Exclusion ranges. IP addresses within the scope that are not to be allocated. Reservation. Assigning a specific IP address to a specific device based on its MAC address. Dynamic assignment. Automatically assigning an IP address from the pool. Static assignment. Manually assigning a specific IP address to a device. Lease time. The duration for which an IP address is valid. Scope options. Additional configurations like DNS servers, gateways, etc. Available leases. The number of IP addresses available for allocation. DHCP relay. Forwards DHCP requests between subnets. IP helper. UDP forwarding. Used to forward broadcast requests as a NICAS to specific servers. DNS, Domain Name System, Record Types. Different types of DNS records serve different purposes. Address, A versus AAAA. A for IP4 and AAAA for IP6. Canonical name, CNAME. Alias for another domain. Mail exchange, MX. Specifies mail servers. Start of authority, SOA. Provides authoritative information about a DNS zone. Pointer, PTR. Maps an IP address to a domain name. Text, TXT. Holds text information, often used for verification. Service, SRV. Specifies the location of servers for specific services. Name server, NS. Specifies the DNS servers for the domain. Global hierarchy. The hierarchical structure of DNS. Root DNS servers. The top-level DNS servers. Internal versus external. Internal DNS for local network, external DNS for Internet. Zone transfers. The process of replicating DNS data across DNS servers. Authoritative name servers. The final authority for a domain's information. Time to live, TTL. The time a DNS record is cached. DNS caching. Temporary storage of DNS queries. Reverse. Forward lookup. Mapping IP to domain, reverse, or domain to IP, forward. Recursive. Iterative lookup. Recursive resolves the query fully, iterative passes it to another server. NTP, Network Time Protocol, Stratum. The level in the NTP hierarchy, lower is better. Clients. Devices that request time updates. Servers. Devices that provide time updates. Corporate and data center architecture. Three-tiered architecture. Core. The backbone of the network, designed for speed and reliability. It routes traffic as quickly as possible. Distribution. Aggregation layer. Connects the core and access layers, often implementing security and filtering policies. Access. Edge. Where devices connect to the network. This layer often includes switches and wireless access points. Software-defined networking, SDN. Application layer. Where the network applications reside, interacting with a control layer to communicate their needs. Control layer. The brain of the SDN, it translates the application layer's needs into changes in the network configuration. Infrastructure layer. The physical components, switches, routers, that actually move packets based on the control layer's instructions. Management plane, used for overall network administration and policy setting. Spine and leaf architecture, software-defined network, uses software control to manage the network. Top-of-rack switching, switches located at the top of each rack, connected to the spine. Backbone, the high-capacity network connection that ties together different networks. Traffic flows, north-south, traffic that moves from the end-user devices towards the data center or cloud and vice versa. East-west, traffic that moves within the data center, typically server-to-server. Branch office versus on-premises data center versus co-location. Branch office, remote locations connected to the main office, often with less infrastructure. On-premises data center, fully owned and operated by the organization. Co-location, renting space in a third-party data center. Storage area networks, SAN, connection types. Fiber channel, iSCSI, FCOE. Fiber channel over Ethernet, FCOE, allows fiber channel to use Ethernet networks. Fiber channel, high-speed network technology primarily used for SANs. Internet Small Computer Systems Interface, iSCSI, uses IP networks to encapsulate SCSI commands, allowing data to be transferred over long distances. Cloud concepts and connectivity. Deployment models. Public. Cloud resources are owned and operated by a third-party cloud service provider and delivered over the Internet. Private. Cloud resources are used exclusively by a single organization. A private cloud can be physically located on the organization's on-site data center or hosted by a third-party provider. Hybrid. A combination of public and private clouds, allowing data and applications to be shared between them. Community. A collaborative effort where cloud resources are shared between several organizations with common goals. Service models. Software as a service, SaaS. Cloud-based applications run on distant servers and are accessed via the web. Infrastructure as a service, IaaS, provides virtualized computing resources over the Internet. Platform as a service, PaaS, provides a platform allowing customers to develop, run, and manage applications. Desktop as a service, DaaS, virtual desktop infrastructure, VDI, hosted by a third party. Infrastructure as code. Automation/orchestration. The use of code to automate the provisioning and management of servers and other infrastructure components. Connectivity options. Virtual Private Network, VPN. Securely extends a private network across a public network. Private direct connection to cloud provider. Direct, secure link from on-premises to cloud. Other concepts. Multi-tenancy. Multiple customers share common infrastructure but remain isolated from each other. Elasticity. Ability to easily add or remove resources. Scalability. The capability of a system to handle a growing amount of work. Security implications. Data breaches, unauthorized access, and other risks are associated with cloud computing. Network implementations. Layer 2 switch. Features. Operates at the data link layer, forwarding frames based on MAC addresses. Placement. Access layer for device connectivity. Layer 3 capable switch. Features. Combines layer 2 switching with routing capabilities. Placement. Distribution layer for routing and LAN segmentation. Router. Features. Routes packets between different networks. Placement. Core layer for connecting different network segments. Hub. Features. Connects multiple devices in the network in a star topology. Placement. Generally outdated. Not recommended for modern networks. Access point. Features. Provides wireless connectivity. Placement. Access layer, usually ceiling mounted for optimal coverage. Bridge. Features. Connects two or more network segments, making them function as a single network. Placement. Access layer to connect different network types. Wireless LAN controller. Features. Manages multiple access points. Placement. Core distribution layer. Load balancer. Features. Distributes incoming network traffic across multiple servers. Placement. Between the firewall and application servers. Proxy server. Features. Intermediary between end users and the Internet. Placement. DMZ or behind the firewall. Cable. DSL modem. Features. Provides Internet connectivity. Placement. Edge of the network, connected to ISP. Repeater. Features. Extends the range of wireless signals. Placement. Between access points. Voice gateway. Features. Converts voice traffic into data packets. Placement. Near VoIP systems. Media converter. Features. Converts between different types of media, e.g., copper to fiber. Placement. Where different media types intersect. IPS. IDS features. Monitors and/or blocks malicious traffic. Placement. Behind the firewall but before the internal network. Firewall. Features. Filters incoming and outgoing traffic. Placement. Network perimeter. VPN headend. Features. Termination point for VPN connections. Placement. DMZ or network edge. VoIP phone. Placement. Near workstations, connected to layer 2 switches. Printer. Placement. Near workstations or in dedicated printer rooms. Physical access control devices. Placement. Entry and exit points. Cameras. Placement. Security sensitive areas. HVAC sensors. Placement. Throughout the building for climate control. IoT devices. Placement. As needed, but segregated on their own VLAN for security. Smart speakers. Thermostats. Doorbells. Placement. Residential areas, also on a separate VLAN. Industrial control systems. SCADA. Placement. Industrial areas, isolated from the main network for security. Bandwidth management and routing technologies. Dynamic routing. Dynamic routing automatically adjusts to network changes. Routers communicate with each other to update routing tables. Protocols. RIP. RIP, Routing Internet Protocol. Distance Vector Protocol, limited to smaller networks. OSPF, Open Shortest Path First. Link State Protocol, suitable for larger networks. EIGRP, Enhanced Interior Gateway Routing Protocol. Cisco Proprietary, hybrid between link state and distance vector. BGP, Border Gateway Protocol. Exterior Routing Protocol, used for routing between ISPs. Link state versus distance vector versus hybrid. Link state. Routers have complete topology knowledge. OSPF uses this. Distance vector. Routers know only about their neighbors. RIP uses this. Hybrid. Combines features of both. EIGRP uses this. Static routing. Static routing. Manually configured routes. No automatic adjustment. Default route. Default route. A route used when no other specific route is available. Administrative distance. Administrative distance. A metric used to choose between multiple routes. Exterior versus interior. Exterior protocols. Used for routing between different organizations. BGP. Interior protocols. Used within the same organization. OSPF. RIP. Time to live. TTL. TTL. Limits the lifespan of data in the network. Bandwidth management concepts. Traffic shaping. Traffic shaping. Controls the amount and rate of traffic sent to the network. Quality of service. QoS. CoS. Prioritizes traffic types to provide different service levels. Comparison. Purpose. Routing focuses on the optimal path for data packets. Bandwidth management focuses on how data flows through those paths. Flexibility. Dynamic routing is flexible and adjusts automatically. Traffic shaping and QoS require initial setup but can be dynamic. Complexity. Routing protocols can get complex, e.g., BGP. QoS settings can also be complex but are generally easier to manage. Scope. Routing is generally concerned with internal and external network data paths. Bandwidth management is usually an internal concern. Hardware. Routing is done by routers. Bandwidth management can be done by routers, switches, or specialized devices. Metrics. Routing uses metrics like cost, distance, etc. Bandwidth management uses metrics like latency, jitter, etc. Administrative overhead. Static routing and manual CoS settings require more administrative effort. Real-time changes. Dynamic routing protocols can adapt to network changes in real time. CoS and traffic shaping are generally not as agile. Security concerns. Routing protocols have various security features. Scenario. Setting up a secure and efficient local network for a small business. Data VLAN and Voice VLAN. Data VLAN. Isolate different departments into separate VLANs for security. Voice VLAN. Separate VLAN for VoIP to ensure quality. Port configurations. Assign ports to VLANs. Port tagging, 802.1Q, and port aggregation. Use 802.1Q for VLAN tagging. Use port aggregation for increased bandwidth. Link Aggregation Control Protocol, LACP. Use LACP for better link aggregation management. Jumbo frames. Enable jumbo frames for better performance. AutoMDIX and MAC address tables. AutoMDIX for automatic cable detection. MAC address tables for network mapping. Power over Ethernet, PoE, and PoE+. Enable PoE for devices like IP cameras. Spanning tree protocol. Prevent network loops. Carrier sense multiple access with collision detection. CSMA, CD, RRP, and Neighbor Discovery Protocol. CSMA, CD, Legacy Collision Detection. RRP, resolves IP to MAC addresses. Neighbor Discovery, IP6 equivalent of UP. 80211 Standards. Concepts. 80211A. Older standard. Operates at 5 GHz, up to 54 megabits per second. 80211B. Operates at 2.4 GHz, up to 11 megabits per second. 80211G. Operates at 2.4 GHz, up to 54 megabits per second. 802.11n, Wi-Fi 4. Operates at 2.4 GHz and 5 GHz, up to 600 megabits per second. 802.11 AC, Wi-Fi 5. Operates at 5 GHz, up to 1.3 gigabits per second. 802.11 AX, Wi-Fi 6. Operates at 2.4 GHz and 5 GHz, up to 9.6 gigabits per second. Installation and configuration. Router selection. Choose a router that supports your desired standard. Firmware update. Always update the router's firmware to the latest version. Configuration. Access the router's admin panel to select the standard you want to use. Antenna types. Concepts. Omni. Radiates signal in all directions. Directional. Focuses signal in a specific direction. Installation and configuration. Antenna selection. Choose based on your coverage needs. Placement. Place the antenna in an optimal location. Testing. Use tools like Wi-Fi Analyzer to test signal strength. Frequencies and range. Concepts. 2.4 GHz. Longer range but slower and more congested. 5 GHz. Shorter range but faster and less congested. Installation and configuration. Router configuration. Choose the frequency in the router settings. Placement. Higher frequency, 5 GHz, requires closer proximity to the router. Channels. Concepts. Regulatory impacts. Different countries have different allowed channels. Installation and configuration. Channel selection. Use auto selection or choose a less congested channel. Regulatory compliance. Ensure you are using channels allowed in your country. Channel bonding. Concepts. Combining multiple channels to increase throughput. Installation and configuration. Router settings. Enable channel bonding in the admin panel. Service Set Identifier, SSID. Concepts. Basic Service Set, BSS. Single Access Point. Extended Service Set, ESS. Multiple Access Points. Independent Basic Service Set, Ad Hoc. Peer-to-peer network. Roaming. Switching between access points within an ESS. Installation and configuration. SSID configuration. Set SSID name and type, BSS, ESS, or ad hoc, in the router settings. Encryption standards. Concepts. WPA Wi-Fi Protected Access. WPA2 Personal. AES. TKIP Temporal Key Integrity Protocol Encryption for Home Networks. WPA. WPA2 Enterprise. AES Advanced Encryption Standard. TKIP Encryption for Enterprise Networks. Installation and configuration. Encryption settings. Choose the encryption standard and type in the router settings. Cellular technologies. Concepts. CDMA. Code Division Multiple Access. GSM. Global System for Mobile Communications. LTE. Long-term evolution. 3G, 4G, 5G. Different generations. Installation and configuration. Carrier selection. Choose a carrier that supports your desired technology. MIMO and New MIMO. Concepts. MIMO. Multiple input, multiple output. New MIMO. Multi-user MIMO. Installation and configuration. Router selection. Choose a router that supports MIMO or New MIMO. Device compatibility. Ensure your device is also supported. Network operations. Performance metrics. Sensors. Device. Chassis. Metrics. Device uptime, availability. Sensors. Internal system monitors. Temperature. Metrics. Current, average, and peak temperatures. Sensors. Thermal sensors in the device. CPU usage. Metrics. CPU utilization percentage. Sensors. System level monitoring tools. Memory. Metrics. RAM usage, swap space. Sensors. System level monitoring tools. Network metrics. Bandwidth. Data rate supported by a network connection. Latency. Time taken for a packet to go from source to destination. Jitter. Variation in packet delay. SNMP, Simple Network Management Protocol, traps. Metrics. Unsolicited alerts sent from SNMP agents to managers. Object identifiers, IDs, metrics. Unique IDs used to recognize various SNMP objects. Management Information Bases, MIBs, metrics. Hierarchical databases storing metadata and information about network objects. Network device logs. Log reviews. Metrics. Failed login attempts. Configuration changes. Traffic logs. Metrics. Data packets sent/received. Source/destination IPs. Audit logs. Metrics. User activities. Permission changes. Syslog. Metrics. System messages and errors. Logging levels. Severity levels. Metrics. Categorizes logs based on their severity. Debug. Info. Warning. Error. Interface statistics. Status. Link state. Up. Down. Metrics. Current status of the network interface. Speed. Duplex. Metrics. Data rate and transmission mode. Half duplex. Full duplex. Send. Receive traffic. Metrics. Amount of data sent and received. Cyclic redundancy checks. CRCs. Metrics. Error checking technique. Protocol packet and byte counts. Metrics. Number of packets and bytes sent. Received for each protocol. Interface errors or alerts. CRC errors, giants, runts, encapsulation errors. Metrics. Various types of network errors. Environmental factors and sensors. Temperature, humidity, electrical, flooding. Metrics. Environmental conditions affecting network hardware. Baselines. Metrics. Standard levels for network performance. NetFlow data. Metrics. IP traffic flow data. Uptime/downtime. Metrics. Duration for which the system has been up or down. Installation and configuration. Monitoring tools. Use SNMP managers, syslog servers, and network monitoring solutions. Sensor placement. For environmental factors, place sensors at strategic locations. Baseline configuration. Establish performance baselines for comparison. Logging. Configure logging levels and storage. Plans and procedures. Change management. Purpose. To ensure that all changes to the IT environment are recorded, evaluated, and managed in a controlled manner. Incident response plan. Purpose. To provide a structured approach for handling various types of security incidents like data breaches. Disaster recovery plan. Purpose. To outline the steps for recovering critical IT systems and data after a catastrophic event. Business continuity plan. Purpose. To ensure that essential functions continue to operate during and after a disaster. System life cycle. Purpose. To manage the entire life cycle of a system from inception through decommissioning. Standard operating procedures. Purpose. To document routine operations to ensure consistent execution and compliance. Hardening and security policies. Password policy. Purpose. To specify requirements for creating, managing, and storing passwords. Acceptable use policy. Purpose. To define what is considered acceptable usage of company resources and data. BYOD policy. Purpose. To manage risks associated with employees using their own devices for work. Remote access policy. Purpose. To control remote access to internal networks. Onboarding and offboarding policy. Purpose. To standardize the process of adding or removing employees in the organization. Security policy. Purpose. To outline the organization's approach to maintaining information security. Data loss prevention. Purpose. To prevent unauthorized access and sharing of sensitive information. Common documentation. Physical network diagram, floor plan, rack diagram. Purpose. To provide a visual representation of the network and its physical components. IDF. MDF documentation. Purpose. To document the main and intermediate distribution frames. Logical network diagram, wiring diagram. Purpose. To illustrate how network devices are logically connected. Site survey report. Purpose. To assess the feasibility and requirements for a network at a particular location. Audit and assessment report. Purpose. To document the findings of security audits and assessments. Baseline configurations. Purpose. To document the standard settings used in the organization's systems. Common agreements. Non-disclosure agreement, NDA. Purpose. To protect sensitive information from being disclosed. Service Level Agreement, SLA. Purpose. To define the level of service expected from service providers. Memorandum of Understanding, MOU. Purpose. To outline the terms and details of a partnership, including each partner's requirements and responsibilities. High availability and disaster recovery concepts. Load balancing. Purpose. Distributes network or application traffic across multiple servers. Multipathing. Purpose. Uses multiple physical paths to provide fault tolerance and improved performance. NIC teaming. Purpose. Combines multiple network interface cards to act as a single channel. Redundant hardware. Clusters. Switches, routers, firewalls. Purpose. Provides fault tolerance and high availability. Facilities and infrastructure support. UPS, PDU, generator, HVAC, fire suppression. Purpose. Ensures that the physical environment is stable and resilient. Redundancy and high availability, HA, concepts. Cold site, warm site, hot site, cloud site. Purpose. Different types of backup sites for disaster recovery. Active versus active passive. Purpose. Describes how redundancy is implemented. Multiple ISPs. Diverse paths. Purpose. Ensures continuous internet connectivity. VRRP Virtual Router Redundancy Protocol. FHRP First Hop Redundancy Protocol. Purpose. Provides router or gateway redundancy. MTTR mean time to repair, MTBF mean time between failures, RTO recovery time objective, RPO recovery point objective. Purpose. Metrics for measuring reliability and recovery capabilities. Network device backup/restore. State. Configuration. Purpose. Ensures that device settings can be quickly restored. Best solution. The best solution depends on the specific needs, budget, and risk profile of the organization. However, a comprehensive approach often includes redundant hardware for immediate failover, load balancing and multipathing for optimized resource utilization, hot site or cloud site for quick disaster recovery, multiple ISPs to ensure uninterrupted internet access, UPS and generators for power redundancy, regular backups, including both state and configuration of network devices, metrics monitoring, using MTTR, MTBF, RTO, and RPO to continuously assess the reliability and recovery capabilities. Network security. Common security concepts. Confidentiality, integrity, availability, CIA, confidentiality. Ensuring that data is accessible only to authorized users. Integrity. Ensuring data is not tampered with. Availability. Ensuring that data and services are available when needed. Threats. Internal. Threats originating from within the organization. External. Threats originating from outside the organization. Vulnerabilities. Common vulnerabilities and exposures, CVE. Publicly disclosed vulnerabilities. Zero-day. Vulnerabilities unknown to the vendor. Exploits. Purpose. Code or methods used to take advantage of a vulnerability. Least privilege. Purpose. Granting only the permissions necessary to perform a task. Role-based access. Purpose. Assigning permissions based on roles within the organization. Zero trust. Purpose. Assumes no trust and verifies everything before granting access. Defense in depth. Network segmentation. Dividing the network into segments. Perimeter network, DMZ. An additional layer between the internal network and the external network. Separation of duties. Dividing tasks and privileges among multiple people or systems. Network access control. Restricting network access based on policies. Honeypot. Decoy systems to lure attackers. Authentication methods. Multi-factor. Using more than one method for authentication. TACAX Plus. Terminal Access Control or Access Control System Plus. SSO. Single Sign-On. Radius. Remote Authentication Dial-in User Service. LDAP. Lightweight Directory Access Protocol. Kerberos. Network Authentication Protocol. Local Authentication. Authentication on the local machine. 8021X. Network Access Control. EAP. Extensible Authentication Protocol. Risk Management. Security Risk Assessments. Evaluating security risks. Threat Assessment. Identifying potential threats. Vulnerability Assessment. Identifying potential vulnerabilities. Penetration testing. Simulated cyber attacks. Posture assessment. Overall security status. Business risk assessments. Evaluating business-related risks. Process assessment. Evaluating processes for security risks. Vendor assessment. Evaluating third-party vendors for security risks. Security Information and Event Management, SIEM, purpose. Real-time analysis of security alerts generated by various hardware and software infrastructure. Best practices. Implement defense in depth. Layered security measures. Regular assessments. Regularly conduct various types of assessments. Use SIEM tools. For real-time monitoring. Apply zero trust and least privilege. For access control. Common attacks. DOS. DDoS. DOS. Overwhelms a single server with excessive requests. DDoS. Uses multiple systems to perform a DOS attack. Botnet. Command and control. Botnet. A network of compromised computers. Command and control. The server that controls the botnet. On-path attack. Man in the middle. Purpose. Intercepts and possibly alters communication between two parties. DNS poisoning. Purpose. Redirects a domain name to a different IP address. VLAN hopping. Purpose. Gains access to a different VLAN. ARP spoofing. Purpose. Links an attacker's MAC address with the IP address of a legitimate user. Rogue DHCP. Rogue AP. Rogue DHCP. Unauthorized DHCP server. Rogue AP. Unauthorized access point. Evil twin. Purpose. A malicious AP that mimics a legitimate one. Ransomware. Purpose. Encrypts files and demands a ransom for decryption keys. Password attacks. Brute force. Tries all possible combinations. Dictionary. Uses a predefined list of words. MAC spoofing. Purpose. Imitates another MAC address. IP spoofing. Purpose. Imitates another IP address. Authentication. Purpose. Disconnects a user from a network. Malware. Purpose. Malicious software like viruses, worms, and trojans. Human and environmental attacks. Social engineering. Purpose. Manipulating people into revealing confidential information. Phishing. Purpose. Fraudulent emails that mimic legitimate organizations. Tailgating. Purpose. Following an authorized person into a secure area. Piggybacking. Purpose. Gaining network access through another person's legitimate connection. Shoulder surfing. Purpose. Observing someone's screen or keyboard to gain information. Comparison and contrast. Technology-based attacks usually exploit vulnerabilities in software or hardware. They can often be mitigated through technical means like patches, firewalls, or intrusion detection systems. Human and environmental attacks exploit human behavior and physical security. They require a different set of countermeasures like awareness training and physical security protocols. Network hardening. Best practices. Secure SNMP. Private VLANs. Isolates ports within the same VLAN. Disable unneeded switch ports. Physically disable or shut down unused ports. Disable unneeded network services. Turn off services like Telnet, HTTP if not needed. Change default passwords. Always change vendor-supplied defaults. Password complexity. Length. Enforce strong password policies. Enable DHCP snooping. Filters out untrusted DHCP messages. Change default VLAN. Move away from VLAN 1. Patch and firmware management. Keep all software up to date. Access control list and role-based access. Define who can access what. Firewall rules. Explicit deny. Explicitly block certain traffic. Implicit deny. Deny all that is not explicitly allowed. Wireless security. MAC filtering. Allow or deny clients based on MAC address. Antenna placement. Place antennas in secure and optimal locations. Power levels. Adjust to minimize signal leakage. Wireless client isolation. Prevent clients on the same SSID from communicating with each other. Guest network isolation. Isolate guest traffic from internal networks. Pre-shared keys, PSKs. Use strong keys for WPA. WPA2. EAP. Use extensible authentication protocol for better security. Geofencing. Limit access based on geographical location. Captive portal. Used for guest network access control. IoT access considerations. Limit IoT device capabilities and network access. Use network segmentation for IoT devices. Remote access methods. Site-to-site VPN. Purpose. Connects entire networks to each other. Security. Usually secured with IPsec. Implication. Requires careful configuration to ensure that only authorized traffic is allowed. Client-to-site VPN. Purpose. Connects individual users to a network. Security. Can use SSL, TLS or IPsec. Implication. Easier to manage but can expose the network if client security is compromised. Clientless VPN. Purpose. Allows remote access through a web browser. Security. SSL, TLS, based. Implication. Limited in capabilities and reliant on web security. Split tunnel versus full tunnel. Split tunnel. Only traffic for the remote network goes through the VPN. Full tunnel. All traffic goes through the VPN. Implication. Full tunnel is more secure but can be slower. Remote desktop connection. Purpose. Allows control of a remote PC. Security. Can be encrypted but is often targeted by attackers. Implication. Needs strong authentication and encryption. Remote desktop gateway. Purpose. Allows RDP over HTTPS. Security. SSL. TLS encryption. Implication. More secure than basic RDP. SSH. Purpose. Secure shell for remote terminal access. Security. Strong encryption and authentication. Implication. Widely considered secure but needs proper configuration. Virtual Network Computing, VNC. Purpose. Remote desktop access. Security. Varies. Can be secured with SSH. Implication. Less secure than other methods if not properly configured. Virtual desktop. Purpose. Provides a virtualized desktop environment. Security. Depends on the underlying infrastructure. Implication. Can be secure if properly isolated. Security considerations. Authentication and authorization. Multi-factor authentication and strong authorization policies are essential. In-band versus out-of-band management. In-band management traffic is mixed with regular traffic. Out-of-band. Separate channel for management traffic. Implication. Out-of-band is generally more secure. Comparison and contrast. VPN methods are generally more secure but require more setup and management. Remote desktop methods are easier to use but often less secure unless additional measures are taken. SSH is secure and versatile but mainly for terminal access. In-band versus out-of-band has trade-offs in terms of complexity and security. Physical security. Importance of physical security. Prevents unauthorized access. Physical security measures prevent unauthorized individuals from gaining physical access to sensitive areas where they could directly interact with hardware. Protects against internal threats. Even within an organization, restricting who has physical access to certain assets is crucial. Compliance. Many regulations require physical security measures as part of compliance standards. Data protection. Physical access can lead to data theft, data corruption, or hardware damage. Business continuity. Ensures that critical assets are physically secure, contributing to business continuity plans. Detection methods. Camera. Surveillance cameras act as both a deterrent and a means to identify unauthorized individuals. Motion detection. Sensors can alert security personnel about unauthorized movement in sensitive areas. Asset tags. RFID or barcodes can help in tracking the physical location of assets. Tamper detection. Alerts if someone attempts to open or modify hardware. Prevention methods. Employee training. Educating employees about the importance of physical security is the first step in prevention. Access control hardware. Includes electronic locks, gates, and other mechanisms that restrict access. Badge readers and biometrics. Ensure that only authorized individuals can enter certain areas. Locking racks and cabinets. Secure servers and other critical hardware. Access control vestibule, man-trap, 2 sets of doors that require authentication, ensuring that potential intruders cannot tailgate authorized users. Smart lockers. For secure storage of sensitive or valuable items. Asset disposal. Factory reset. Wipe configuration. Ensures that no sensitive data remains on the device before it is disposed of or repurposed. Sanitize devices for disposal. Physically destroying hard drives or using secure erase methods. Network troubleshooting methodology. 1. Identify the problem. Gather information. Collect logs, error messages, and any other data that could be relevant. Question users. Ask users about what they experienced, what they were doing when the issue occurred, etc. Identify symptoms. Slow network, packet loss, etc. Determine changes. Check if any updates, new installations, or configurations have been made recently. Duplicate the problem. If possible, recreate the issue for better understanding. Approach multiple problems individually. If more than one issue exists, tackle them one at a time. 2. Establish a theory of probable cause. Question the obvious. Don't overlook simple issues like cable connections, power supply, etc. Consider multiple approaches. Top to bottom OSI model. Start from the application layer and move downwards. Bottom to top OSI model. Start from the physical layer and move upwards. Divide and conquer. Isolate sections of the network to narrow down the issue. 3. Test the theory to determine the cause. Confirm or refute theory. Use diagnostic tools and tests to confirm your theory. Next steps or re-establish theory. If confirmed, plan the next steps for resolution. If not, form a new theory or escalate the issue. 4. Establish a plan of action. Outline the steps needed to resolve the issue and consider the potential impact on the network or users. 5. Implement the solution or escalate. Either resolve the issue yourself or escalate it to higher-level support or specialists. 6. Verify full system functionality. Ensure that the solution has resolved the issue and hasn't caused new ones. Implement preventive measures to prevent the issue from recurring. 7. Document findings. Keep records of the issue, how it was diagnosed, and how it was resolved. This is crucial for future troubleshooting and for organizational knowledge. Connectivity troubleshooting. Specifications and limitations. Throughput. The data rate supported by the cable. Lower throughput can cause bottlenecks. Speed. The speed at which data can be transmitted over the cable. Distance. The maximum length the cable can run without signal loss. Cable considerations. Shielded and unshielded. Shielded cables offer protection against interference but are more expensive. Plenum and riser rated. Plenum cables are used in air circulation spaces. Riser cables are used between floors. Cable application. Rollover cable / console cable. Used for terminal connections. Crossover cable. Used to connect like devices without a switch. Power over Ethernet, PoE. Transmits both data and electrical power. Common issues. Attenuation. Signal loss over distance. Interference. External signals affecting the cable's signal. Decibels, loss. Measurement of signal loss. Incorrect pinout. Wrong cable termination. Bad ports. Damaged or non-functional ports. Open. Short. Open circuit or short circuit in the cable. LED status indicators. Can indicate the health of the connection. Incorrect transceivers. Mismatched or faulty transceivers. Duplexing issues. Mismatch in duplex settings. TX. RX reversed. Transmit and receive wires are reversed. Dirty optical cables. Can cause signal loss. Common tools. Cable crimper. For attaching connectors. Punch-down tool. For inserting wire into patch panels. Tone generator. To trace cables. Loopback adapter. For testing ports. Optical time domain reflectometer, OTDR. For measuring the quality of fiber optic cables. Multimeter. For measuring electrical properties. Cable tester. For checking if the cable can transmit data successfully. Wire map. To verify wiring configuration. Tap. For monitoring data. Fusion splicers. For joining optical cables. Spectrum analyzers. To analyze frequencies. Snips. Cutters. For cutting cables. Cable stripper. For removing insulation. Fiber light meter. To measure optical signal strength. Software tools and commands. Software tools. Wi-Fi analyzer. Helps in optimizing Wi-Fi networks by scanning for channels and signal strength. Protocol analyzer. Packet capture. Tools like Wireshark can capture and analyze network packets for troubleshooting and security analysis. Bandwidth speed tester. Measures the speed of your internet connection. Port scanner. Tools like MAP can scan for open ports and identify services running on servers. iPerf. Measures the bandwidth and the quality of a network link. NetFlow analyzers. Collects and analyzes NetFlow data to monitor network traffic behavior. TFTP server. Used for transferring files to and from network devices. Terminal emulator. Software like PuTTY for accessing network devices via SSH or Telnet. IP scanner. Scans a range of IP addresses to find hosts that are alive and obtain information about them. Command line tools. Ping. Tests network connectivity between devices. ipconfig. Ifconfig. IP. Shows the IP configuration of a device. NSLOOKUP. Dig. DNS lookup tools. Traceroute. TraceRT. Shows the path packets take to reach a destination. UP. Displays and modifies the UP cache. Netstat. Shows network statistics like open ports and active connections. Hostname. Displays the hostname of the device. Root. Manages routing tables. Telnet. Tests port connectivity. TCP dump. Captures network packets for analysis. Nmap. Network mapper for security scanning. Basic network platform commands. Show interface. Displays information about network interfaces. Show config. Displays the current configuration of the device. Show route. Displays the routing table. Wireless troubleshooting. Specifications and limitations. Throughput. The actual data rate of the wireless connection, which can be affected by interference and signal strength. Speed. The theoretical maximum speed of the wireless standard being used, e.g., Wi-Fi 4, 5, 6. Distance. The range of the wireless signal, which can be affected by obstacles and interference. RSSI, Received Signal Strength Indication. A measure of the power level received by the wireless client. EIRP, Effective Isotropic Radiated Power. Power settings. The total output power radiated by the wireless AP access point. Considerations. Antennas. The type and placement of antennas can significantly impact signal strength and range. Placement. The location of the AP can affect coverage and signal strength. Type. Omnidirectional or directional antennas serve different purposes. Polarization. The orientation of the radio waves, which can affect signal quality. Channel utilization. Overutilization can lead to performance issues. AP association time. Time taken for a client to associate with an AP. Site survey. A comprehensive study to plan and design the wireless network. Common issues. Interference. Other electronic devices or networks can cause signal interference. Channel overlap. Multiple APs on overlapping channels can cause interference. Antenna cable attenuation. Signal loss. Poor quality or long antenna cables can result in signal loss. RF attenuation. Signal loss. Physical obstacles can reduce signal strength. Wrong SSID. Connecting to the wrong network. Incorrect passphrase. Incorrect security key for network access. Encryption protocol mismatch. Incompatibility between client and AP encryption settings. Insufficient wireless coverage. Dead spots where the signal doesn't reach. Captive portal issues. Problems in the login page for network access. Client disassociation issues. Clients getting frequently disconnected from the AP. General troubleshooting. Considerations. Device configuration review. Check the settings on routers, switches, and other network devices. Routing tables. Ensure that routes are correctly set up and that there are no unnecessary or conflicting routes. Interface status. Check the status of network interfaces on devices. VLAN assignment. Ensure that VLANs are correctly assigned and configured. Network performance baselines. Compare current performance metrics to established baselines to identify anomalies. Common issues. Collisions. Occur in a shared medium, often due to duplex mismatches. Broadcast storm. Excessive broadcast traffic affecting network performance. Duplicate MAC. IP address. Two devices with the same MAC or IP address can cause network instability. Multicast flooding. Excessive multicast traffic can overwhelm network resources. Asymmetrical routing. Traffic taking different paths in each direction can cause issues with stateful firewalls. Switching. Routing loops. Loops in the network topology can cause endless traffic loops. Rogue DHCP server. Unauthorized DHCP servers can disrupt network operations. DHCP scope exhaustion. Running out of available IP addresses in the DHCP scope. IP setting issues. Incorrect gateway, subnet mask, or IP address settings. Incorrect DNS. DNS misconfigurations can lead to name resolution issues. Missing route. Absence of necessary routes in the routing table. Low optical link budget. Issues in fiber optic links due to signal loss. Certificate issues. SSL. TLS certificate issues can disrupt secure communications. Hardware failure. Physical failure of network devices. Firewall settings. Host-based or network-based firewalls can block necessary traffic. Block services, ports, or addresses. Ensure that essential services are not being blocked by ACL or firewalls. Incorrect VLAN. Mismatched or misconfigured VLANs can segment the network improperly. DNS issues. Problems with DNS resolution or DNS server settings. NTP issues. Incorrect time settings can cause authentication and logging issues. BYOD challenges. Security and connectivity issues related to bring your own device policies. Licensed feature issues. Some network features may require licenses that have expired or are incorrectly configured. Network performance issues. Could be due to bandwidth limitations, latency, or packet loss. Acronyms. AAAA. Authentication, authorization, accounting, auditing. ACL access control list. AES advanced encryption standard. AH authentication header. AP access point. APC angled physical contact. APIPA automatic private internet protocol addressing up address resolution protocol. AUP acceptable use policy. BGP border gateway protocol. BNC British Naval connector. Bayonet Neil Consolman Bayard bring your own device. CAM content addressable memory table can campus area network. CDMA code division multiple access. CIA confidentiality, integrity, and availability side of classless inter-domain routing. CLI command line interface. CNAME canonical name. CPU central processing unit. CRC cyclic redundancy check. CSMA. CA carrier sense multiple. Access with collision avoidance CSMA. CD carrier sense multiple access. With collision detection CSU channel service unit. CVE common vulnerabilities and exposures CWDM coarse wavelength division multiplexing DAS desktop as a service. Decibels decibel. DDoS distributed denial of service. DHCP dynamic host configuration protocol. DLP data loss prevention. DNS domain name system. DOS denial of service. DSL digital subscriber line. DSU data service unit. DWDM dense wavelength division multiplexing. EAP extensible authentication protocol. EIA Electronic Industries Association. EIGRP Enhanced Interior Gateway Routing Protocol. EIRP effective isotropic radiated power ESP encapsulating security payload EUI extended unique identifier. FCOE fiber channel over Ethernet. FHRP first hop redundancy protocol. FTP file transfer protocol. Gbit gigabit interface converter. GRE generic routing encapsulation. GSM Global System for Mobile Communications High Availability. HDMI High Definition Multimedia Interface HTTP Hypertext Transfer Protocol. HTTPS Hypertext Transfer Protocol Secure. HVAC Heating, Ventilation, and Air Conditioning. IaaS Infrastructure as a Service. ICMP Internet Control Message Protocol ICS Industrial Control System. IDF Intermediate Distribution Frame IDS Intrusion Detection System. IGMP Internet Group Management Protocol IMAP Internet Message Access Protocol. IoT Internet of Things. IP Internet Protocol. IPS Intrusion Prevention System. IPsec Internet Protocol Security. IPv4 Internet Protocol version 4. IPv6 Internet Protocol version 6. iSCSI Internet Small Computer Systems Interface ISP Internet Service Provider. LACP Link Aggregation Control Protocol. LAN Local Area Network. LC Local Connector. LDAP Lightweight Directory Access Protocol. LDAP's Lightweight Directory Access Protocol, over SSL, LED Light Emitting Diode. MIMO Multiple Input, Multiple Output. MIMO Multi-User, Multiple Input, Multiple Output. MOU Memorandum of Understanding. MPLS Multi-Protocol Label Switching. MTBF Mean Time Between Failure. MTRJ Mechanical Transfer, Registered Jack. MTTR Mean Time to Repair. MTU Maximum Transmission Unit. MX Mail Exchange. NAC Network Access Control. NUS Network Attached Storage. NAT Network Address Translation. NDA Non-Disclosure Agreement. NFV Network Function Virtualization. NGFW Next Generation Firewall. NIC Network Interface Card. NS Name Server. NTP Network Time Protocol. ERID Object Identifier. OSI Open Systems Interconnection. OSPF Open Shortest Path First. OTDR Optical Time Domain Reflectometer. PaaS Platform as a Service. PAN Personal Area Network. PAT Port Address Translation. PDU Power Distribution Unit. PoE Power over Ethernet. POP3 Post Office Protocol version 3. PSK Pre-Shared Key. PTR Pointer Record. QoS Quality of Service. QSFP Quad Small Form Factor Pluggable. RA Router Advertisements. Radius Remote Authentication Dial-in User Service RAID Redundant Array of Inexpensive or Independent Disks RDP Remote Desktop Protocol. RF Radio Frequency. RFC Request for Comment. RG Radio Guide. RIP Routing Internet Protocol. RJ Registered Jack. RPO Recovery Point Objective. RSSI Received Signal Strength Indication. RTO Recovery Time Objective. RTSP Real-Time Streaming Protocol. SaaS Software as a Service. SAN Storage Area Network. South Carolina Standard Connector/Subscriber Connector. SCADA Supervisory Control and Data Acquisition. SDN Software Defined Network. South Dakota 1 Software Defined 1. SFP Small Form Factor Pluggable. SFTP Secure File Transfer Protocol. SIEM Security Information and Event Management SIP Session Initiation Protocol. SLA Service Level Agreement. SLAAC Stateless Address Auto Configuration. SMB Server Message Block. SMTP Simple Mail Transfer Protocol. SNMP Simple Network Management Protocol. SOA Start of Authority. SOHO Small Office Home Office. SQL Structured Query Language. SRV Service Record. SSD Solid State Drive. SSH Secure Shell. SSID Service Set Identifier. SSL Secure Sockets Layer. SSO Single Sign-On. ST Straight Tip or Snap Twist. STP Spanning Tree Protocol. Syslog System Log. TACAX Plus Terminal Access Controller Access Control System Plus. TCP Transmission Control Protocol. TFTP Trivial File Transfer Protocol TIA. EIA Telecommunications Industry Association. Electronic Industries Alliance TKIP Temporal Key Integrity Protocol. TLS Transport Layer Security. TTL Time to Live. TX. RX Transmit and Receive. UDP User Datagram Protocol. UPC Ultraphysical Contact. UPS Uninterruptible Power Supply URL Uniform Resource Locator. USB Universal Serial Bus. UTP Unshielded Twister Pair. VIP Virtual IP. VLAN Virtual Local Area Network. VM Virtual Machine. VNC Virtual Network Computing. VNIC Virtual Network Interface Card. VoIP Voice over Internet Protocol. VPN Virtual Private Network. VRRP Virtual Router Redundancy Protocol. One Wide Area Network. WAP Wireless Access Point. WDM Wavelength Division Multiplexing. WLAN Wireless Local Area Network. WPA Wi-Fi Protected Access.